In this video, we're going to talk more about parallel lines and the transversals and how if I'm looking at that type of diagram, how I can solve equations related about them. So let's go ahead and look at a couple of examples and you'll see just these same type of examples on your assignment. So in our first diagram, it says below we have these lines K and N that are parallel to each other, and we want to find the values of X and Y. So the very first thing I do when I look at this diagram is remember if these two lines are parallel, okay, and they have this line crossing through them, okay, I kind of like think of these like my side streets and this like the interstate that crosses through them both. If those two streets are parallel, that means that if I were to snip my road in half and I were to pick up this chunk and I were to set it down on top of this, okay, that they would overlap. Because they're parallel, this angle, if I pick it up and I move that dot right there, it's going to line up with here. This angle is going to line up with here. This angle is going to line up with here. And this angle is going to line up here. Remember the other thing that we talked about is because these lines are parallel and they're straight, they make a linear pair. So if I look at this line right here, this angle and this angle add together because they form the straight line. They add together to give me 180. So what I can do is I can find out what one of my missing angles. So if I take 180 and I subtract 74 and I get a total of 106, that means this angle right here is 106. That also means that if I were to pick this up and set it over here, remember that this also equals 106. This angle lines up here, so that's 74. Hey, remember that I can find out what any of the angles are by continuing to find those linear pairs. So if I look at this line right here, this plus this equals 180. 180 minus 106 is 74. This is a line, 106. And remember, I have got these vertical pairs. These diagonals are always equal to each other. Okay, same thing with this intersection. The diagonals are always equal to each other. So that's 106, 106, that's 74, 74. And I think I pointed this out in one of the last videos on these parallel lines. But notice I've got this alternation. 106, 74, 106, 74, 106, 74, 106, 74. And it's going to continue to follow that same pattern. Now that I have this set up, I really only have to come up with a few things, a few equations. So first off, this information right here tells me that X is 106. So when it asks what X is equal to 106. When it asks for Y, well, remember Y is in the middle of this 3Y plus 16. But this entire 3Y plus 16 is equal to 106. So we write an equation. 3y plus 16 equals 106. I draw my equal sign. Here's my y. And remember, I get whatever's further from y first. So I'm going to subtract 16, total everything up. I bring down 3y, I bring down my equal sign, and I bring down the 90. My last step is that because that's multiplication, we undo it with division, and I end up with y is equal to 30. So y is equal to 30 and x is equal to 106. Let's look at another example to make sure we've got it. So if I have, again, my two lines, they're being intersected by my main line. Okay, I have some pairs. If this intersection lines up right over here, if I pick it up and set it down, this angle right here is also 72. And I'm going to pick something other than yellow that does not show up very well. 72. Well, I know that this angle should line up with this. So if I can figure out what that squiggly angle is, then we're good. Remember that because this is a straight line, 72 plus my unknown is equal to a total of 180. So we take our calculator, 180, let's clear it, 180 minus 72, 108. So this missing angle is 108. And same reason, if I stack that on top of over here, that's also 108. Remember from our last problem, we've got that alternating thing going on, or those vertical angles. These diagonals are equal to each other. So since this angle is 108, this angle is 108. because this angle 72, this angle 72, because this angle 72, this angle 72, because this angle's 108, this angle's 108. Let's answer for Z and for Y. Z, which is in this angle right here, just says Z and then 108. So I have Z is equal to 108. My second equation, says that this angle for Y minus 48 is equal to 72. So I don't know what Y is. Y is still a question mark, so let's solve it. I'm going to draw my line down my equal sign. There's my Y, and I'm going to get rid of whatever's further. Because it says minus 48, I'm going to add 48. Total everything up. 72 plus 48. 72 plus 48 is 120. So 4y is equal to 120 divided by 4. 120 divided by 4 is 30. So on this one, y is equal to 30. Z is equal to 108. Okay, so I've got this pattern going on. So if I look at this last problem and I want to do a different example, because notice this time my parallel or my side streets are running horizontally. So this intersection, if I pick it up and slide it down, it's going to line up here. That means this 73 degrees is going to line up. If I pick it up and set it down, it's going to line up right here. So that's 73. Remember, how do we get the other angles? Okay, the diagonals are always the same, so I can already fill that in. That's 73. The diagonals are the same, so 73. How do I get those remaining 4 angles? Remember, 108 minus that 73 because I've got a line. So 180 subtract 73 is 107. So 107, 107, 107, and 107. Let's find our two answers. Z is equal to 107. It's labeled there. Z is 107. And 5y minus 28 is also equal to 107. But that doesn't mean y is. We're going to solve. We add 28. We add 28. We get 5y is equal to 135 divided by 5 on both sides. And 135 divided by 5 is 27. So y is equal to 27. All right, hopefully those few examples are going to lead you on the right track to finishing your assignment. If you have any questions, please reach out.